Hello. Thank you for coming here today. My name is Joe Darcy. I work in Oracle's Java Platform Group, and I'll be speaking today about JDK 9 language, tooling, and library features. In case we don't have time for Q&A at the end of the talk, if you tweet at this hashtag JDK9 lang tools libs, I can answer questions there. The last slide of the talk will also have a URL to the PDF of the slide deck. So this is Oracle's safe harbor statement. It lets you know you shouldn't put too much trust in what I have to tell you here today, especially regarding forward-looking statements. However, since the talk is about JDK 9 and JDK 9 just shipped, there aren't very many forward-looking statements in this talk. It might get a bit repetitive seeing Oracle's safe harbor statement throughout the conference. If you want some tips for alternative safe harbors in the area, I'll be happy to provide those afterward. A quick survey before we get started. Which JDK train are you using in production? Are there any very early adopters on JDK 9 yet? Well, that's understandable. How about who's downloaded the JDK 9 JDK? All right, that's good. Maybe some more people after the talk or after the talks at the conference will download it. JDK 8 in production? All right, almost everyone. JDK 7? All right, about a quarter. JDK 6? One or two stray hands. Now we're all friends here. So who will admit to using JDK 5 or older in production still? All right, a few honest people in the audience, yes. Those were great releases, but we have many features since then, so hopefully you'll be able to try those out soon. Overview of JDK 9. As I mentioned, JDK 9 just shipped recently a few weeks ago. Like the last few JDK projects, it was developed under the auspices of OpenJDK, so if you're interested in participating in that development, following the mailing list, trying out the builds, you can find more information on the OpenJDK website. Throughout this talk, I'll be using the term JEP. JEP is a JDK enhancement proposal. These are documents we use for feature tracking in the JDK. And if you go to the OpenJDK page for JDK 9, you will see a long list of the JEPs there, about 90 JEPs. We won't be talking about all of them today. But besides many JEPs, JDK 9 had many bug fixes. This is a comparative chart of number of bug fixes in 9 versus 8. So as you can see, JDK 9 has almost 20,000 fixes in it, which is slightly less than twice what JDK 8 had. So a very large release all around, including Jigsaw functionality and many other features we'll be talking about. So no talk about JDK 9 would be complete without some mention of modularity, Project Jigsaw. Project Jigsaw was a very large feature, and the modularity functionality from Jigsaw is to make programming in the large easier. Modules bund together one or more packages as a unit of reuse and offer stronger encapsulation than jar files. One reason Jigsaw was a large project was because it required changes throughout many aspects of the platform, the language, tools, and libraries. The language changes for Jigsaw include a new kind of file, a module info.java file, which declares dependencies between modules. Javac was updated to support that new kind of source file, as well as to find dependencies through modules. There were corresponding updates made to the Java command and the hotspot runtime to understand the modularity restrictions. And there were also API changes. Those API changes include updates to the core reflection and the language model to model the new aspects of the platform. Now, there's much more to be said about modularity than can fit in a single 45-minute session. For that reason, the Jigsaw team has 5 45-minute sessions here at Java 1. Some of these have already occurred. They may be being given again later in the conference, so you can check the scheduling app for that. And a few other sessions are later this afternoon or later in the conference. For this talk, we'll start next by talking about our approach to stewardship of the Java platform. Then we'll talk about the tooling, language, and library updates. While some of those features are pretty distinct, sometimes a feature will involve more than one area. And if we have time at the end, some Q&A. So stewardship. The approach we use for stewardship for the JDK is very different from the stewardship approach used by, say, Denethor in the King's films, who was the steward of Gondor. The number one goal of the Java platform group for the last 7.5 years has been to keep Java vibrant. Part of keeping Java vibrant means keeping the things that work today working tomorrow. So that topic is compatibility. So the fundamental policy we have about the JDK is managing compatibility in a sensible way. The general evolution policy is we don't want to break binary compatibility as defined in the Java language specification. That means we want programs that link today to be able to link tomorrow. We want to avoid introducing source incompatibilities. That is where programs stop compiling, or if they compile, they mean something different. And we want to manage the behavioral compatibility, what a method does when you call it. Now, this philosophy applies to the API changes we make in the platform, but it also applies to the language features we have. For instance, because of this policy, we still recognize old version 45.3 class files generated by Java 1.0 over 20 years ago. We limit the cases where legal code stops compiling in newer platform releases, and we want to avoid changes in the semantics of code generation when recompiling. So as with any sort of compatibility policy, one of the trade-offs here is finding the right balance between stability and progress. So we have three kinds of compatibility: source, binary, and behavioral. And if we remember back in physics class, we could graph this as a three-dimensional diagram. And different kinds of releases have different kinds of compatibility regions that are acceptable. So if we take, say, the security update releases, those quarterly releases that come out 4 times a year, they have a very small region to make changes. There's some behavioral change, of course, because we want to fix the vulnerability, and maybe there's a little bit of source compatibility for a JDK-specific API. If we have a larger release, such as the update releases like 8U20 and 8U40, those are much larger, so they have more room for behavioral change and more opportunity to make source changes. However, in both of these cases, there's no room for binary incompatible changes. We don't want to break people on an update release because we want people to use those update releases as soon as they come out. For a platform release like JDK 8 GA or JDK 9 GA, the situation is a bit different. There's the maximum amount of room to make behavioral changes and more room to make source changes. And in exceptional circumstances, with enough justification, there's even the possibility to make some binary incompatible changes. And I'll mention a few of those that were made in JDK 9 later in the talk. This is an example that helps illustrate the compatibility policy and how it applies to different releases. So if we look at the specification for hashset.iterator, it says you get back an iterator, and the elements are returned in no particular order. That means, according to the specification, we can change the iteration order at any time in any release and still obey the specification. So how does this change square with the compatibility policy? Well, this would be a binary compatible change because we're not altering the set of methods. It's also a source compatible change because the compilation of a client doesn't depend on the internals of the method body. So you can change the method body and that won't change whether or not the client compiles. However, this is a behavioral compatibility change. And we know people can and do implicitly and sometimes accidentally rely on the iteration order. Therefore, this is a kind of change that we generally wouldn't make in either kind of update release, but we would make and have made in a platform releases. And the reason we'd make it in a platform release is to take advantage of, say, better hashing algorithms. So this is the terminology for compatibility that's used in the JDK 8 and JDK 9 release guides and compatibility documents. So I recommend you look at those when you look to migrate to those releases. So how is JDK 9 different? JDK 9 follows this same model of looking after compatibility, but to support modularity, a larger compatibility impact than usual was allowed, including some notable behavioral incompatibilities. For example, if you're using a tool that assumes the existence of rt.jar, you'll have to update to a newer version of the tool that doesn't rely on that because rt.jar has gone away. It's no longer in the JDK 9 image. That information is stored differently. To support modularity, there were even a few cases where we broke binary compatibility. There was an unfortunate dependency between the logging framework and between Java.desktop. So we don't want to suck in all of Java.desktop anytime you want to use logging, and we fixed that by getting rid of these property listener methods that weren't crucial to the API. Later on in the talk, I'll also talk about the more muscular deprecation policy we have with better tools to manage the transition going forward. So now we'll start talking about some of the tooling improvements, and the first of those tooling improvements is JShell. Lisp systems have generally provided a read, evaluate, print loop as the primary way you interact with that system. So you type commands and the system evaluates it and it gets back to you. Similar functionality is found in Ruby and Python, and on the JVM ecosystem languages, also Scala, Groovy, and Clojure. So what about Java? Well, now in JDK 9, we also have a REPL, and the REPL is called JShell. I'll do a quick demo of that. Get the right window up here. All right, so JShell is a new command in the JDK bin directory, so we'll get that started here. So there are commands in JShell preceded by /, so we can do help intro as it suggests here, and we get some guidance on using the tool. But if we're using a new language environment, what's the first program we want to write? Hello world. So we can just start typing hello world here, and we'll see what happens. Now, we get back hello world. Now, that's a nice thing to have, not very complicated, but notice we didn't have to deal with public static void, main, string, all those things. So if you just want to do some informal programming and get started, you can do it right away. So besides expressions, we can define variables in JShell. So let's say we want to define a double variable named tau, and we want that to be equal to twice pi. So we know there's a pi constant in the math class. So if we start typing math, we can get autocomplete here. These are the alternatives, so we can pick math. And then if we look in math where the variables begin with p, we see there's pi there. And if we hit tab a few more times, we'll see that we can get the documentation for pi, and we can see it is indeed the constant we're looking for. Of course, fields aren't very interesting by themselves. You also want methods, so we can say define a method named square that takes a double and returns the square of it. And besides auto-completing on elements of the JDK, we can also auto-complete on fields and methods we've defined ourselves. So we can say take the square of the sine of tau, autocomplete, and we have some command line editing, so we can cut and paste that. So if we square the sine and square the cosine of something, we should get something close to 1. And that is indeed what we get in this case. And then we can exit out of the shell. So going back to the slides here. So this is good for students. There's less ceremony getting started, but JShell is not just for novice programmers. It's helpful for experienced programmers too. If you want to start exploring using a new API, like the new APIs in JDK 9, I found JShell helpful myself in helping to prepare for this and other talks. So JShell has snippets, those expressions, as well as Java commands. The JShell implementation is interesting. It leverages many existing JDK technologies, including the compiler API and the debugger API, and there's a user's guide to help get started. Now, while we might not have Taco Tuesday at Java 1, we do have JShell Wednesday. So tomorrow there are 4 talks about JShell. The first of these is by Robert Field, who is the architect and lead engineer of JShell. And if Robert hears you like JShell, he might show you how to invoke a nested JShell from within JShell. So you can use a REPL while you're using a REPL. And if you don't catch Robert's talk, there's other ones to catch here. Next, we'll talk about a few changes in Javadoc. So for many years, Javadoc has output HTML 4.01. A few years ago, HTML5 was a new standard. And now Javadoc has an option to output HTML5 instead of the older HTML 4.01. And this is the version of HTML we use for the JDK documentation now. People might have seen the Doclet checks in JDK 8. These are checks you can run from Javadoc or from Javac to validate the Javadoc comments. We added some more configuration options to Doclet, in particular to select which packages you want the checks to apply to. So in the JDK build, for instance, we primarily check the Java and JavaX packages because we want the documentation we publish to be free of these sorts of problems. The Lint checks range from the syntax of the HTML tags to their semantics, and you can enable and disable them individually if you haven't finished clearing one category of warnings from your build yet. In terms of the implementation of the Doclet, The Doclet API is very old. It dates back to very early JDKs. And with the benefit of hindsight, the API modeling the Java language could be improved. Since the Doclet API, we actually have several other reflective APIs in the platform that are better suited to allow language evolution. So we've re-implemented the standard Doclet on top of a Javac line model API, which is supported in the compiler. So this gives us a better base for Javadoc improvements going forward. Another feature we have is Javadoc Search, and I'll go back to do a demo of that. So this is a download of the JDK 9 Javadoc. There are a few changes to notice. One is that it's divided into a few sections. There's a standardized Java SE documentation. There's also documentation for JDK-specific classes as well as JavaFX altogether. The frames view is still available, but it's not the default. And if we scroll down, we'll see that the primary organization is done by modules. So we have all the Java SE modules, then the modules that are in the JDK, and so forth. And at the top right-hand corner, we have a search box. So let's say we're interested in finding more about math. This is a math. So we see here that we get back search results over package names as well as type names and field names. And from here, we can navigate to those sorts of things. Now, we know in Java sometimes the names are very long. That's part of the convention. So if we wanted to find, say, the equals ignore case method, that would be a lot of typing, but we actually don't have to type that all out because the Javadoc search supports camel case search. So if you start typing EQ and then IG, we can get the equals ignore case method straight away. All right, we'll go back to the slides. So the implementation is in JavaScript in the client, so you don't have to go to the server for that. If you wanted to find your own index terms, there's a tag to allow you to do that as well. What it does currently is it indexes over the names of the modules, packages, types, and fields, and so forth. The next two features are designed to ease getting from one JDK release to another. The first of these is cross-compiling with the -- release flag to Javac. So for many years, the advice in the Javac man page and in blogs I've written and others have written has been to cross-compile to an older JDK. There were three things you needed to do. You had to set the source version to the older release, the target version, and finally, the boot class path to the older release. People didn't always follow this guidance, so we get a flow of bugs in there, and we wanted to do something about that. A related policy change was to limit the range of source and target values we support in Javac. Starting in JDK 8, we don't support all the way back to the beginning anymore. We support the current release and then 3 back. So in JDK 9, we support 9 as well as 8, 7, and 6. And 6 is deprecated because we plan to remove it the next time we remove a release. And something similar will be done for JDK 10, which is probably going to be called 18.3 or one of the subsequent releases. Now, why do you need to set the boot class path? Well, let's say we have two versions of the JDK here, and there's a library. And in the first version, there's a foo method that takes a double. And then as an optimization in a later JDK release, we add a foo method that takes an integer. So that's a perfectly compatible change according to our compatibility policy. And let's say we have the client library here that uses foo, and we compile it against JDK n+1. So which of the two foo methods is the compiler going to choose for foo 1, 2, 3, 4? It's going to choose the foo that takes an integer. That's the most specific foo version, and that's what the language specifies. Okay, so what happens if we take that file, compile it against JDK n+1, and we run it against JDK n? We'll get a runtime error, something like this. No such method error. What the detail message of the error here is saying, the VM is looking for a foo that takes an integer, but it's not finding one. It's not finding one in JDK n because it isn't there. There's only a foo method that takes a double. So this is the kind of problem people can run into when you don't set the boot class path when you cross-compile. So since we still had this problem, we talked about it in the Javac team. We added a warning if you didn't set the boot class path when using older versions. We did that back in JDK 7, but the problem still persisted. And we were talking about it on the team, and we said, you know what? We know what people actually want to do here. They just want to cross-compile to the old version. So why don't we just let them do that directly instead of having to set these three variables? and that is indeed what we've done now with the javac release end flag. Semantically, it's equivalent to setting the source and target to the older release, as well as the boot class path. However, the information about the boot class path is available to javac. So this is shipped as part of the JDK in a compressed fashion, so you don't have to manage that kind of state yourself anymore. A few advantages of this: you don't have to worry about managing those old rt.jar files yourself. If you use Maven plugins like Animal Sniffer that's meant to prevent using wrong APIs, you should have less need for that. Another advantage, if you're doing this cross-compilation, is you might be able to take advantage of newer compile idioms in Javac. There are bug fixes in Javac, and sometimes there are very large performance improvements. One of the projects we had in Javac in JDK 9 was called tiered attribution, which helps speed up type inference in some sorts of situations. So the steeply rising curve there was the JDK 8 runtime in seconds, and you'll notice it's a log scale, so it is getting quite slow quite quickly for these very small programs that were using type inference in a particular way. So a straight line on a log scale is basically exponential growth, so that's not very good if you want to have a scalable compiler environment. So we want to do something else, so we re-engineered how inference worked, and we got these much faster lines on the bottom. So we both get that using Javac from JDK 9, and we get that sort of performance using the Javac from JDK 9 using -- release 8. So if you're cross-compiling to 8, you get the benefit of the re-engineering we've done in the newer compiler. The next feature is multi-release jar files. So it's inconvenient if you want to package up a library for distribution to make one version of the library for different versions of the JDK. So typically you'll compile for the oldest JDK you plan to support and then distribute that instead. So if you actually want to use the features in newer JDKs, it's a bit awkward. And from our perspective, it slows adoption of the new features of the JDK, and we of course want people to use them. So sometimes you can get around that by using reflection to test for the new APIs, but that's kind of slow and awkward. And the modularity features put in 9 make some shouldn't be used APIs that are so tempting to use, some of those Sun.star APIs, out of reach or harder to get to. So what's the alternative? The alternative here is multi-release jar files. In a multi-release jar file, there's a shared common area across the releases, and then there are directories in the meta-inf area that overload or provide version-specific class files to be used in particular JDK releases. So for instance, there's a subdirectory for JDK 9, and then you use those files when you're running on JDK 9 as opposed to files you'd use on JDK 8. There are a few things to do with this. One thing you can do is you can create a jar file that acts as a regular old jar file on JDK 8 and earlier, but acts as a new modular jar file on JDK 9. You do that by having the module.info.class files available in the 9-specific area. You can create these multi-release jar files using the jar command, and we've updated the other APIs that consume jar files, Java, Javac, and jar signer to be multi-release aware. There's tooling support for creating multi-release jar files. Ant and Maven have documented ways to do that. And recently, Trisha posted a demo code to create multi-release jar files in IntelliJ. So you can check your local tool documentation for details. Next, we'll start talking about the small language changes that were made in JDK 9. Back in JDK 7, we had a project called Project Coin that added half a dozen small language changes for the platform. And for 3 of those changes, we had some cleanup work we wanted to do, work we couldn't quite finish by the end of JDK 7. So those are the top 3 here. Project Lambda, which was added in JDK 8, also had a few small items to clean up, so we kind of grouped those together and also fixed those in JDK 9. The first of these is safe Varargs on private instance methods. So back in JDK 5 or 6, we could write code like this. We have a list of strings, and we want to help initialize that using the arrays.eslist platform class. So if you were careful about your compiler warnings, you notice you'd get a warning like this. Warning, unchecked generic array creation for Varargs parameter of the arrays.eslist method. So what's going on here? This warning is mandated by the Java language specification, and it's letting you know that something bad might be happening. The something bad is called heap pollution, which would be a violation of Java's type constraints. And if the arrays.eslist method was malicious and not implemented properly, it could be causing this kind of heap pollution. However, in this case, nothing bad actually happens. Raise.asList in the platform is not a malicious method, so this error is a false positive. It's uninformative. So uninformative warning messages aren't good, so we addressed this problem back in JDK 7 by adding the safe Varargs annotation type. And the safe Varargs annotation type lets you tell the compiler that your Varargs method is not in fact malicious and it shouldn't warn people about it. So this does two things. Both it removes warnings when you declare the Varargs method, and more importantly, it removes warnings every time people call the Varargs method. So we applied this annotation to arrays.asList and the other appropriate methods in the platform. Because of the design of annotations, annotations are only inherited on classes, not interfaces or methods. Therefore, the safe Varargs annotation can only be used on methods that can't be overridden. So what kinds of methods can't be overridden? Final methods, static methods, also constructors, which from a certain point of view are just very special static methods. So are there any other kinds of methods that can't be overridden? There are private methods, and we forgot about those ones in JDK 7. But now we've changed the specification in implementation to also allow safe Varargs on private methods. So if you have such a method, you can now use the annotation on it. The next change we made deals with the try with resources statement. So just as a quick refresher, you have your resource R being managed, and behind the scenes, the compiler creates an implicit finally block for you to call close on the resource, as long as it's not null. Now, in full disclosure, the actual code the compiler uses is a bit more complicated. This is the actual desugaring here. The extra complexity is to give better exception handling, but we don't have to worry about this. The compiler takes care of it for us. So in JDK 7, the resource being managed had to be a fresh variable associated with the try with resources statement. That wasn't the initial proposal, however. Originally, you could use any expression with the right type, which was auto-closable, meaning a close method was there. But we found there's a problem using that. So let's say we initialize our resource R to a new resource object, and then within the try block, we make R point to a different resource object. Now we come to the end of the try block, and what are we supposed to do? Which object is supposed to get its close method called? Well, we decided we didn't want to have to solve this problem. And the way we decided not to solve it was to require that new final variable as part of the try with resources statement. But this was actually a little bit stricter than would need to be. So if we already know that some resource variable is final or effectively final, why do we have to declare a new fresh final or variable to take care of it? There's really no reason to do that. And that is indeed the change now we've made in JDK 9. So if you already have a final variable, you don't have to make a new one. You can just reuse the one you have. So it makes the try with resources statements a bit more concise. Dimond and anonymous classes, that's the next feature we'll be talking about. So back before JDK 7, if you had your list of map of strings to integers, you'd declare the variable, and then in the constructor call, say array list, you'd have to repeat list of map of string of integer. That was a bit verbose, so now you can just have the Dimond, and the compiler will infer those type arguments for you. This was very effective at removing the need for explicit constructor type arguments. However, due to a bad worst-case interaction, we had to forbid using Dimond when you were using anonymous inner classes. The problem is, in the worst case, the compiler could infer something called a non-denotable type. This is a type outside of the type system we can use as programmers, but exists inside the compiler. And the problem is, if you have an anonymous class, that needs a class file, and part of the information in the class file it needs is the type arguments, and if you have a non-denotable type inferred, it's outside what you can write in the class file, so that's bad. So in other cases, though, if you get a denotable type inferred, one of the normal types we usually deal with, that could be represented in the class file. So we noted that we had to forbid Dimond and anonymous classes working together at all in 7, but when we were finishing up Project Coin, we said it's feasible that in the future we might remove this restriction in the case when you get a denotable type and you avoid that worst case. And that is indeed, in fact, what we've now done in JDK 9. So as long as you don't get that worst case outcome, you can use Dimond with anonymous classes too. In JDK 7, Dimond let us get rid of about 90% of the explicit constructor type arguments, and we feel with this cleanup for denotable types, we can address much of the remaining 10% We've had good experience using this feature in the JDK code base. It's let us get rid of hundreds of additional explicit constructor arguments in our code. Next two features are from Project Lambda. So underscore is no longer an identifier name. Back when Lambda was added in JDK 8, you couldn't use underscore as the parameter name for a Lambda. That was to avoid confusion with some features from other programming languages like Wonderbar from Scala. JavaC started noting, though, that if you're using underscore in other circumstances as an identifier, you might not be able to use them in the future, and now that future has arrived. You can no longer use underscore as a variable name in JDK 9. So this is not our usual policy of keeping code compiling, but why are we making this change? Well, we think there's better use for the syntactic real estate of a single underscore for a variable name, and that work is being discussed in a future JEP, JEP 302 Lambda leftovers, which is part of Project Amber, one of our ongoing projects in OpenJDK. Finally, we have private interface methods. Another part of Project Lambda in 8 was adding default methods to interfaces. These are methods on interfaces that have code, so they're not the abstract methods we had before. And at the VM level, it's possible to have private methods on interfaces in 8. These were necessary to implement lambdas. However, you couldn't do that in the source language. And now in Java 9, you can. You can have both private static methods on your interfaces as well as private instance methods. So what would you do with these methods? You can use them as helper methods for the other default methods you have in the interface, the public methods. So this is, again, very, very convenient to have once you start adding default methods to your own interfaces. So you may have heard at the keynote or earlier about the new 6-month release cadence we're transitioning to for the JDK. One of the benefits we think we'll have from this release cadence is that these sort of small language changes will be delivered more quickly, and they won't be backed up behind a large language change before. So we're looking forward to that, to get these sorts of small language cleanups available to developers sooner. There are a number of changes we made to the language related to deprecation. The first of those is deprecation and imports. Like any old code base that's been around for a while, at times we had some technical debt in the JDK, and in years past we've had several hundred deprecation warnings in the build of the JDK itself. Now these warnings are again mandated by the language specification, and there's 3 ways to resolve those deprecation warnings. You can remove use of the deprecated elements. That's preferred, but you can't always do that. You can propagate the deprecated annotation to the use sites. That's not very good either, because now you're making more of your code deprecated. So if you can't do either of those, you can suppress the warnings to let the compiler know to not warn you about that anymore. So let's say you had your client library on JDK 5 through 8, and it was used some deprecated type in the JDK. You compile this, and you get your deprecation warning. So you figure, no problem, I have to keep using this type, so I'll just put that suppress warnings annotation right at the top of the class, and this will take care of everything, right? Now, unfortunately, if you run the compiler again, you'll notice you still have a deprecation warning. So what's going on here? The warning you're getting now isn't from any of the code of the class. It's actually from the import statement at the top. And this is mandated by the Java language specification. You might say, well, that's not a problem. I'll just apply another suppress warnings annotation. That doesn't work either. Syntactically, you can't allow that. So while this warning may be very thorough and well-intentioned, it's really unhelpful. If all the other uses of the deprecated type can be covered by the suppress warnings annotation, it seems a bit silly to force you to do something like use the fully qualified name of the deprecated type everywhere just to avoid this warning. So we decided that was a little unnecessary, and we've updated the language specification to not require a deprecation warning in this location. And because of this language change, it is now tractable to clear a code base of deprecation warnings. And we have an existence proof of that by clearing the Java.base module and the Java.desktop module, amongst other modules in the JDK, of deprecation warnings. So if you have such warnings in your own code base, I encourage you to look into them and try to get them under control. Now, there's a bit more to say about deprecation. There's been, over the years, some confusion about deprecation. What does it mean? Is it deprecated because it's harmful? Is it deprecated because it's going away? And if it's deprecated because it's going away, why haven't you JDK guys removed things yet? So we wanted to give more information in this situation, and we did that by enhancing the information available in the deprecation annotation type. There are 2 new methods added. One of those is a predicate for removal that defaults to false. So if something is deprecated for removal true, that means in some relatively near future platform release, we plan to remove it. You also can add a string for the since release that something was first deprecated. We've updated the deprecation annotations in the core platform to have this for removal information, and they're supporting updates made in the language specification, Javac and Javadoc. Also, there's a new static analysis tool in the JDK called JDepreScan that analyzes class files and jar files for the use of APIs that were deprecated in the JDK. So we have had these deprecations, including for removal deprecations. So you don't have to recompile your code, though, to find out, though, if your jar files are affected by it. You can just run JDepreScan on your jar files instead, and you can find out what's going on. Next, we'll talk about some of the library updates that went on in the release. First of these was the new version string. The 1 dot in 1.8 and 1.7 and so forth has gone away. So if you run a version on your new download of JDK 9, it'll just say it's version 9 and it's build 9 plus 181. Don't get too used to this though, because the version scheme will likely change again. Instead of JDK 10, we might have 18.3. Maybe it'll be JDK X or JDK A. We'll see in the coming months what the final name is. But the 1 dot won't be coming back. So if you have tooling that checks for this, it'll have to be updated. If you use Java to talk to native OS processes, there's some additional API elements to control those more directly, including getting the PID. A few interesting features related to strings. The first of these is compact strings, where without any user intervention, if your string doesn't require any of the high bytes to be non-zero, it'll use a 1 byte per character representation as opposed to the old 1 car per character representation. And if you do need the high byte set, it'll use 2 bytes instead. So this can give you a better memory usage for your applications, especially ones using strings, and you don't have to update your application in a way to take advantage of that. The second feature, Indify string concatenation, is a good example of a feature that crosses all of the VM, the language, and well as the compiler like Javac. It's a very common operation in the Java platform to concatenate strings together. Javac happens to do this usually with string builder calls. And then the VM has to notice this idioms used by Javac and other compilers and try to optimize that accordingly. So since this is such a common operation, instead, a new stable entry point was created in Java lang invoke. And the intended user of this API is not programmers, but it's compilers like Javac. So there's a very straightforward way compilers can take advantage of this to communicate with the VM, and it lets the VM know the semantics of the code and generate faster code as a result. So this effectively adds a new JVM capability without having to define a new bytecode. There are a number of updates made to the security libraries. The general security policy is we want the JDK to be secure out of the box. That means we want to restrict broken or weak cryptographic algorithms and protocols. Now, as cryptographers become more clever and computers become faster, which algorithms are weak or broken varies. So Oracle's published a crypto roadmap for the JDK where we announce ahead of time when certain algorithms and protocols will be deprecated or removed from the default set because of those reasons. And that is a document that does get updated as the situation changes. A few highlights to the security APIs in 9. By this secure by default policy, the default key sizes for RSA were increased, and so forth. Also, certificates with weak keys are no longer accepted by default. There are some system settings you can use to still have those certificates accepted if you need them. My colleague, Sean Mullen, gave a talk about making the JDK more secure that covers the JDK 9 security libs features in more detail, and the video for that talk is already up from the conference. There are also updates to the client libraries and FX in the release. Like other parts of the JDK, the FX codebase was modularized. There were updates to graphic support in various ways. A few notable projects. The Marlin graphics renderer replaced the previous Pisces and Ductus renderers. This removed one of the major remaining behavioral differences between Oracle JDK and Open JDK. So now they're, the JDKs are using the same implementation code in both circumstances. And for the photographers who also use Java, there's now support for Tiff Images, including the EXIF metadata. There were a number of talks about the client libraries at Java 1, and you can see them listed here. A few miscellaneous library treats as well. So first of these is convenience factory methods. So how many times have you written code like this, right? At the end, you want to have an unmodifiable set of strings. So what you have to do today, you have your hash set, you call add, and then you have the collections.unmodifiable wrapper. That's a bit verbose for a simple operation, so there are other things you can do. You can use code like this instead, where you initialize the hash set using arrays.eslist, and then you wrap that. That's still a bit long. There's also the double brace idiom, which we won't even show, that some people use. But you don't have to do this anymore in JDK 9. Now you can just write this, set that of, and then what you want to initialize the set to. And what you get out of this is a unmodifiable set of strings. So this idiom is supported on sets, lists, and maps, and it approximates the functionality of collection literals. Collection literals were one of the features we looked at for Project Coin in JDK 7, but we didn't have time to do. This is a good way to get most of that functionality at a small fraction of the complexity of the platform. Now, we mentioned the hashset.iteration order and people relying on that unknowingly. These new collections will discourage that by having a random iteration order for the sets and maps, not for the lists. So every time you create these, you'll get a different iteration order, which will make it more difficult to rely on the iteration order when you're using them. And for more information, my colleague Stuart Marks gave a talk about this feature earlier this morning. If you use Java Util objects for common functionality, we did add some methods there as well, some additional null checking and index checking methods. Some of these have intrinsic support from the VM. A few odds and ends. I am interested in math, so we've had the fuse, multiply, add method added to the platform. This is a hardware instruction that's becoming more and more common. It allows you to do 2 floating point operations with only 1 rounding error, and it's good for some numerical tricks. And this, again, has hardware support on many platforms, so we have intrinsics for those. Also, there are some array comparisons for like graphic array. Those have also been intrinsified. And if you're interested in things like var handles, which is common for concurrent programming using things like C++ atomics, those have been added to the platform as well. And my colleague, Paul Sandoz, gave a talk about those at a conference, the JVMLS conference in 2015. There's some other survey talks about JDK 9 at the conference, if you want to hear other people's takes about what's good there. The first of these, JDK 9 Hidden Gems, focuses more on the VM and performance aspects of the platform, and the video for that is also up online already. So in summary, JDK 9 was a very large release. We've made some fundamental development changes with modularity, but the changes weren't limited to modularity. We also finished long-planned improvements to the language from Project Coin and Lambda. And if you're interested in following future developments, you can do that in OpenJDK, and you can download the JDK 9 bits to try out now. So with that, I think I have time for 1 or 2 questions.
Yeah, with the new dash release, how does that interact with dash source and dash target? Because a lot of them are using Wrangle or using Maven, they're already pre-programmed things.
Right. So the question is, how does the dash release flag interact with dash source and dash target? And the answer is Javac gives an error if you try to do both. So you can do one or the other. You either have to do dash release, where it takes care of everything, or you can use the source and target flags explicitly.
Makes it challenging. You get the tools to change.
The tools will have to change to support it, yes. All right, well, I think that's it. Thank you for coming here today.